In this video, we shall discuss about a .NET internal concept, how the objects are allocated on managed heap. When new heap objects are getting created, they are placed sequentially on managed heap. This way of allocation has certain advantages. In order to know that, we should know the previous heap designs. For example, on native heaps, objects are allocated randomly. Let's see a pictorial representation. Consider this is a native heap block. When objects are created, the objects can be placed anywhere on the heap. We can compare this as a real-time situation of a room where its objects are scattered everywhere. There are many places in between, but there is no effective space. This is called space fragmentation. This scenario is good for even for heap, and there are higher chance of heap fragmentation in native heap. So when .NET designers decided to go for the managed heap design, they understood this problem and they planned a sequential way of allocation of object on the heap so that very less memory in between and there are so many effective spaces. So this way managed heap has reduced fragmentation chances compared to native heap. Now we will go and see a demo where we will verify the .NET managed heap has sequential allocation. Let's go to a demo sample. This is my demo application where there are so many CLR theorems are proved. So here I'm taking a application. I can explain a demo scenario. Consider a furniture shop that has 20 table pair chair. So 10 table objects and chair objects created. Table object is having size of 100,000 byte and chair object with 90,000 bytes. So now we need to verify this particular objects in memory and how they are placed. For that, I want to connect a debugger to this application. I'm opening a Win32 debugger because this application is a Win32. Attaching the process. If the user has dump, they can open the dump. Here I am attaching the process. My test application connected. First thing, I have to load a DLL. This I have explained in previous discussion so that SOS DLL contained the .NET debugging commands. Loaded the DLL. Sorry. Okay, now we loaded the DLL. Now, we know that we have created 10 table and chair object. We want to print them in the memory. For that, we can use a command. This command will print all the heap objects which is size more than 10,000 bytes. We know that our table objects contain 100,000 bytes and chair object with 90,000. So we can so this command will print them. In a real-time situation, there are many objects with this criteria, but this is my demo application. Okay, so we can see the chair, we can see the table object. So how they have been allocated: chair, table, chair, table. This is sequential allocation, and there are no much spaces in between them. I can verify that. I am taking a particular table object address minus the just before the chair address. I should get 90,016. So to include a 90,000 byte object, .NET heap is spending only 90,016. This 16 is actually for a layer, memory layout barrier. So we can see that objects are placed as closer as it can. This is called sequential memory allocation. So now we have proved .NET objects are placed sequentially on the heap. Thank you. We also request our users to go through our previous videos to see the other previous examples.